They're back. Oh my God, I'm so excited to see you. All right, kiddos, what we're going to be doing today is the January 2019 Regents Exam. This is the most recent, as of today, of course. I'm going to be doing parts 2 through 4. So all the extended response questions. No multiple choice. You got what you got in your brain, you got to use, right? Hopefully you did a good job on those multiple choice, and this won't be too bad. If you haven't tried these on your own, try them on your own first, please. If you want to find the other videos or any other Regents videos, just go to my website, go to mrkrausemath.com. Go down to Regents Review, click on Common Core Regents Algebra 2, and then all of them are on here. Hopefully these are the January 19 exams. They should be up and live real soon. Actually, if you're watching it, they're already there. Anyway, all right, let's get going. Without further ado, let me roll down. Page down. I already did all the multiple choice. So let's move. There we go. First question, justify. So the first question says justify. First of all, when you see the word justify, you got to remember that this means words. Yeah, that's the word words and math. So somehow we got to get this to equal this. You don't have to prove it's equal. It's equal. Now you just got to show why it's using, and that's using the properties of rational exponents. So let me rewrite the problem. 3x squared y to the 5th over the 4th root of x cubed y to the 4th. Now here's what should be going on in your mind. You're going to have to write this in some sentences in a second. But this is a root. This is a root. These are the exponents. So this can be rewritten as x to the 2/3 times y to the 5/3, x to the 3/4 times y to the 4/4, but that's just y to the first, right? 4/4. I'm going to just write y to the first. Now, I'm going to write my first sentences. The number, try to write neater, the number on the outside of the radical is the root, which is the denominator of the exponent, which is the denominator of the exponent when written as a rational number. I don't know about you, but I hate writing in math, but you know, it's a necessary evil. All right. And it said say rational exponent, so that's why I use the word rational. So now what you got to remember is when you divide, you subtract the exponents. So if I was to subtract those two, I would get x to the negative 1/12. 2/3 times 3/4 is negative 1/12 times y to the 5/3 minus, actually this is 3/3, it gives me y to the 2/3. So there's the math. Justify, there's math. Done the math. Now I got to do this. When dividing, we simply subtract the exponents. Sorry about that. All right, that's it. That's all that problem has to do. The zeros of the quadratic formula, the function, are 2, -2, 4, and -4. Use the zeros to construct a possible sketch of the function on the axes below. All right, this one's pretty straightforward. -2, -4, 2, and 4. Were those right? All right. So, okay, I can do this. Zeros mean where it hits the x-axis. And since they are symmetric, we might as well draw it like this. Now, if you don't like that, you could have drawn this. Something to that effect. Now, if you want to use your calculator to help you, you got to remember one thing. And that's that simple one thing is that this should be x plus 2. That's for a root of negative 2. X minus 2. That's for a root of x equals positive 2. X plus 4. That's for a root of negative 4. And x minus 4. That's for a root of x. And there's what it looks like. 50, I don't know. So, do you have to make it look like this? No. 100. And then negative 100. See how it looks like this? You know, isn't that what mine looks like? Very symmetric. And the only reason it's going down is if I put a negative. So the roots are here. You got to plot. That's it. Straightforward. Not too bad. Aaron and Christy were working on cubing polynomials for math homework. Aaron believed that she would save time with this wonderful shortcut. No, she wrote down the following for Krista to follow. Does Aaron's shortcut always work? So the answer is no. Aaron is a complete moron. Now, please don't write that on a test. But it's true. Oh, my God. That's the one thing your teacher said. Don't do this. That's just cray-cray. Can't work. So, no, Aaron is not correct. No, period. Aaron is not correct. We have to write the a plus b 3 times and distribute to get the right answer. Now that's worth 1 point because you showed that it's not true. Well, maybe it's worth 1 point. You really got to show that it's not, that it's right, because they said show it algebraically. So that's a plus b, a plus b, a plus b. So in order to do this, you just take two of them. I'm going to take those last two, and I'm going to work with these last two. So I'm going to take a and multiply by both. I get a squared plus ab, and then plus ab plus ab plus b squared. So this is really a squared plus 2ab plus b squared. So now what I'm going to do is I'm going to take the a and multiply by all three of those. A cubed plus 2a squared b plus a b squared. So all I do is multiply the a by that. Now I'm going to do the b by all three. Plus a squared b plus 2ab squared plus b cubed. So my final answer is a cubed plus 3a squared b, this one and this one can be combined, plus 3ab squared, these two can be combined, plus b cubed. Correct answer. Now, how can I make sure that's the correct answer? 100% make sure that's the correct answer. You come over the old calculator. Now, there are calculator tricks that you should be using to at least check your answers. 2.357. Store that into A. 5.369. Store that into B. Enter. Now type in A plus B cubed. Enter, you get some ridiculous number, and then you're going to type in a cubed plus 3a squared times b. Anytime you put two letters next to each other, put a times symbol, plus 3 times a times b squared. Anytime you put two letters next to each other, put a squared, and then plus b cubed. Same number. So I know I got it right. I can guarantee that one. Buddy. All right. I'll be right back. This is the problem we're next. So I know what you're thinking. You're saying, where's the coffee? Oh, don't forget. Of course I have coffee. Freshly brewed downstairs Dunkin' Donuts coffee. All right, kiddos. They don't get any easier than this question right here. They don't get any easier than this question right here. This is the way I do these questions. And I'm going to try to show you the way your teacher might do it. So we're going to read through it. It says the probability of opposing. You should have already read this. The improvements. Opposing improvements is 0.8. The probability. Now here's the other part. We got this word given. The probability resident favors spending on improving walkways given they oppose spending on the plumbing. So this one's opposing plumbing, but favors given opposing. Now that's really kind of confusing. So let's do this a little bit differently. What's the probability they oppose plumbing? That's 0.8. The probability they favor walkways given they oppose plumbing, is equal to 0.85. So the question is, what is the probability they oppose plumbing and favor spending on favor the walkways? Oppose the plumbing and favor the walkways. That's the question mark. Well, you got to remember, this is the formulas I use. The probability of A and B is equal to, I always start with the independence formula. Probability of A times the probability of B. That's the independence formula. This has nothing to do with independence because we got given stuff. So I like to write these like this. All right, so let's just do that. That's the formula we're going to need. Probability of A and B, the probability of opposing plumbing and favoring the walkways, is equal to the probability of opposing plumbing times the probability of favoring walkways given they oppose plumbing. Well, it's just lo and behold, those are the only two numbers in the problem. This was such a ridiculous question. So this is just 0.8 times 0.85. And that is, so the probability of opposing plumbing given, and favoring walkways is equal to, if I multiply those two together, 0.8 times 0.85, 0.68. Now, you could have done it this way. One of your other ways to do it, and one of your teachers taught you, is the probability of favoring walkways given plumbing is equal to, well, this is your given. This is your new universe. So the probability of opposing plumbing would go down here. And in the numerator is, okay, given that you're only opposing plumbing, your new universe is opposing plumbing, what is the probability that they also favor walkways and are opposing plumbing? Well, if I do this, if I use this formula, which is the same exact thing, I get this side is 0.85 over 1 equals probability of favor walkways and oppose plumbing over 0.8. And if I just cross multiply, you end up with the same exact answer. Not bad, kids, not bad. All right, Rowan is trying to run a race. He runs 15 miles in week 1, and the following week is 3% more. This is multiplying. Anytime you have a percent increase, we're going to multiply. And we want to do this over, it says using a geometric series formula. So we have to go use our geometric series formula. That is an incredibly easy formula except for one thing. So A sub 1, 15 miles. Rate is equal to 0.03. But that's going to be the tricky part right there. And you'll see why in a minute. Because this is a 3% increase. But my R value that we have to use is 1.03 because that represents a 3% increase. So if you go over to your formula sheet, it's down here somewhere. It's right here. So S sub n, I hate this form, this n, is equal to S, so that's the sum, is equal to a sub 1 minus a sub 1 times r to the n all over 1 minus r. Now you go back, you triple check it. A sub 1 minus a sub 1 r to the n all over 1 minus r. The only hard part of this formula is remembering that your rate has to be a growth rate. You can't just use 0.03 because that would be a 97% decrease. So S sub n, in this case S sub 10, is equal to, because they wanted 10 years, right? Or 10 weeks. 15 minus 15 times 1.03 to the 10 all over 1 minus 1.03. So we just grab our calculator. Control division, 15 minus 15, parenthesis, 1.03. I still don't understand why they make you use this formula. I like the geometric series formula and the big old E, but for some reason they like this formula. 1 minus 1.03. You get 171, so S sub 10 is equal to 171.958. Since this is miles, they're probably going to just ask you to round the nearest mile. 18967. 18967. I like just doing that. So nearest mile probably. Oh, yeah, I forgot about this problem. Nearest thousandth. Why in the world would anybody ask you to round the amount of running you do to the nearest thousandth of a, what is this, mile? Give me a break. Thousandth of a mile. Yeah, I ran. You know what I ran? I ran 171 point. Let's see what the answer actually is. 171 point, and that's the thousandths place. 958 miles. Really? That's great. Thanks, buddy. There we go. That problem's bodied. You guys got that one, right? That wasn't a bad one. The only hard part, again, is remember, when you use that formula, the only hard part is this, that rate thing. All right, let's do another one. Hopefully we're going to go up. The average monthly temperature in Buffalo in degrees is modeled by this. Okay, so we're talking about average monthly rate. This is slope, kids. This is slope. It said January is 1, so we're going to go from August, which is the 8th month, to November, which is the 11th month. Now, there is one key thing you got to remember about this. You must be in radian mode. Unless you're subbing in degrees, you should be in radian mode. All right, so we got to figure out what those 2 points are. So first of all, let's do our average rate of change, AROC, is equal to the change in y's, the y's go on top, over the change in x. Well, the change in x is pretty simple. That's just going to be 11 minus 8. So let me figure out what my 2 points are. August and something, November and something. They didn't give a lot of room for this problem. That's really embarrassing. So I'm going to come over here and substitute this stuff in. So I'm going to do 8, and I'm going to store that into t. And I'm going to type this sucker, and I got to look down, sorry, 25.29 times the sine of 0.4895 t minus 1.9752. Do you know what one of the common mistakes made on this problem are? Because it's such a ridiculous question. Just type in the doggone numbers wrong. 55.2877. This might be one you just want to do twice. So 56.14. Yeah, it's not even what I got. So 8 store t. So that's not even right. I already typed something in wrong. I know I did. 25.29 the sine. Oh, son of a gun. I even said it. Look at this. I'm in degree mode. I got to be in radian mode. I only check because I want to check my answer because I know these are such a pain. You got to be in radian mode. Son of a gun. I almost made that mistake myself, and I already told you about it. So there we go. Should be 78 something. There we go. 78. Now don't round yet, kids. 78.86622. 86622. Let's see if that's right. 4977. And then now the cool thing is I don't have to retype that. I just go like this. This. Change this to 11. Hit the up arrow. Now I get 48.597.960. Now don't use those numbers. Go like this. You're going to do control division. This one, which is the 11, minus this one up here, which goes with the August, all over 11 minus 8. Now you got to make sure you did it the right way. The 11 goes with the 48. So 48 over 11, the 78 over the 8. So we got that right. Enter. Negative 10 points. So I should write this up here. 48.597.960 minus 78.6622. And so my ARODs, my average rate of change, is going to be equal to negative 10.1. Now, let's see what this is. This is the average high temperature in Buffalo from August to November. So the question says explain. Now, explain means words. What does it mean? All this means is the average temperature in Buffalo, actually average high temperature in Buffalo decreases 10.1 degrees every month from August to November. That's it. Bodied, over with. All right, kiddos, let's do one more, and then I will pause it for a second. So as you read this question, the point M, t, comma 4.7 is located in the second quadrant on the unit circle. Now that's the most important thing. As soon as they say unit circle and you're given a point, this is the cosine of theta and this is the sine of theta. Now they want the exact value of t. Well, what are they really asking for? They're really asking you for cosine of theta, only because it's the unit circle. So, because of that, come over here to your obnoxious thing, and you're going to draw your bow tie. You're going to be working in one of these four triangles, where these are going to be always your theta. Now, it said we're in the second quadrant. That's this one. Okay. So, this is sine. So, sine is 4 over 7. Well, I know sine is opposite over hypotenuse. Oh, opposite 4 over 7. Now I just got to find x. Oh, I can do the Pythagorean theorem. 4 squared plus x squared equals 7. 7 squared. So this is 16 plus x squared equals 49. X squared equals 33. Now here comes the tricky part, chillin'. You got to take the square root of both sides. And you got to remember, when you take the square root, you put a plus or minus. So x is equal to plus or minus the square root of 3. 33. But since we're in the third quadrant, wouldn't you have to say that this value right here is negative radical 33? Oh, yeah. And cosine, we know, is adjacent over hypotenuse. So this t value has to equal adjacent over hypotenuse. Negative radical 33 over 7. And really they were testing this simple fact right here, that you remember that when you have a unit circle, that x is the cosine and y is the sine. And then it's not a bad problem, just right triangles. Wow, this is a really fair test. I really like this test. It's not a bad test. It's very fair. The one thing you have to remember about graphing a log function is there is always an asymptote, right? So just be careful that there's an asymptote. The normal asymptote is right here along the y-axis. But that's not the case in here because we're moving 3 to the right. So I know my asymptote is going to be right here at x equals 3. Now, if you don't know that, then you can also do this using graph. You will do this using graphing. As a matter of fact, I'm going to plot these points, x and y. And I'm going to come over to my graphing calculator and graph this sucker. So go into graphing calculator mode, control log, was it base 2? Base 2 of x minus 3 plus 1. All right, so control T. Now you'll see, look at that. At 3 it's undefined, but at 4 it's not. That makes 3 the asymptote. You cannot cross that. But I'm going to put these on here. 4, 1, 5, 2, 7, 3, and 11, 4. So as long as I graph those, I'm good. And as long as I don't cross that x-axis. So here we go. 4, 1, 5, 2, 6, 7, 3, 8, 9, 10, 11, 4. So it's 5, 6, 7, 8, 9, 10, 11, 4. So come down. Don't touch that asymptote. And graph to the right. That's it. That's all she wrote. Done. All right, we're on to this one. We only got, what, 5 questions left. We're almost done. So first thing we're going to do here is get our answers. A equals, B equals, C equals. A equals, B equals, and C equals. So we're going to type these suckers in. You can either do this using matrices or you can use this calculator. All right, so I'm going to do that here. I'm going to go into calculator mode. Menu, algebra, solve a system of equations, solve a system of linear equations. I have 2 equations. Press tab. It's A, comma, B, comma, C. Make sure you change those. Otherwise, it makes it a little bit more difficult. So it's A plus 2B, or not to be, except it's 4B, plus 6C equals 23. Type them exactly in as they appear. A plus 2B, or not to be, plus C equals 2. And then they got this weird one at the end. It's 6B, just be careful, plus 2C. Type it in exactly as it appears, plus A plus 14. Oops. Equals A plus 14. Enter. All right, there we go. A equals -3. B equals 1/2. And C equals 4. All right, so those are the answers. But we're going to do it algebraically, otherwise we get nothing. So I'm going to put these 2 together, and I'm going to get rid of A. So A plus 4B plus 6C equals 23. And I'm going to do that by multiplying this one by -1. So -A minus 2B minus C equals -2. So these go, and I get 2B plus 5C equals 21. So that's one of my new equations. Now I'm going to take these 2 and put them together, but I got an initial problem. I need to bring this A over. So I'm going to subtract this A over. So this equation becomes -A plus 6B plus 2C equals 14. Now, if you look at this equation and this equation, I don't have to do anything. The A's just cancel, which is really, really sweet. So A plus 2B plus C equals 2. -A plus 6B plus 2c equals 14. Put these suckers together, the a's cancel. I end up with 8b plus 3c equals 16. Now look at the b's and c's. Which one would be easier to get rid of? Hopefully you said the b's, right? Because if I take this and multiply by -4, isn't that give me the opposite or the additive inverse of 8b? Sure. So the 8b I'm not going to change. This one I'm going to multiply this whole thing by -4, so I get -8b minus 20c equals -84. That's the hard part. You got to multiply everything through. We are almost done. I get -17c equals -68. Divide by -17, divide by -17, and I believe c is equal, I think that's 4. C is 4, good. So I got the first part. Now I'm going to take the positive of one of these two. It doesn't matter, just use this one. 8b equals, plus 3 times 4 equals 16. This is 12, so I'll just subtract 12. And so I get 8b equals 4. Divide by 8, and I get b equals 1/2. Perfect. Now I'm going to look at the originals and find the one that's the simplest to use, and that's going to be this one. This was the easiest one to use. A 2bc. So I'll do that in a different color. A plus 2b plus c equals 2. So I'll plug the c in, I'll plug the b in, and I'll find a. So a plus 2 times 1/2 plus 4 equals 2. So a plus 2 plus 1, 2 times 1/2 is 1, plus 4 equals 2. So this is 5, so I'll subtract 5, and I get a equals -3. Shabam! Done. That's it. Wow, that wasn't bad. All right, so this next problem is a really cool problem. It's division. There's something really, really tricky about it. I hope you guys noticed it right away, guys and girls. I hope you noticed it right away. And that is that the x squared is missing. And you're not allowed to do division with that x squared missing. So that's a problem. We have to put that back in. Now, before I even do this, if x plus 2, by the remainder theorem, I can check a of -2 to see what my remainder is going to be. And that's what I'm going to do. And actually, if you look at it, it's actually part of part B. So I'm going to figure out what a of -2 is. So I'm going to take my calculator. I'll just leave it right there. -2. Hold on. Let's get rid of this. So -2. I'm going to store it into x. And then I'm going to type in just the original problem, which is x raised to the 4th plus 2x cubed plus 4x minus 10. And I get -18. So my remainder better be -18. So I know my remainder is going to be -18. Now this is all work that's not part of this one. They want us to do division. They want us to do the division. So that's what we're going to do. X to the 4th plus 2x cubed plus 0x squared. Now you're going to come into play. This doesn't have anything to do with it, but it could, and it probably normally does. All right. What do I have to multiply x by to get x to the 4th? And that's x cubed. So I'll take x cubed times x. I get x to the 4th. X cubed times 2, I get positive 2x cubed. Now here's where it gets a little weird. We're going to subtract and subtract. Well, those go and those go, which gives me 0x cubed plus 0x squared. So those kind of all go. Now I'm just going to bring these two down. 4x minus 10. Well, what do I have to multiply x by to get 4x? Oh, plus 4. 4 times 8, or 4 times x is 4x. 4 times 2 is plus 8. I'm going to change the sign, so subtract and subtract. These go away, and I get negative 18, which is what I expected to get. So I got to write it in this term, the quotient, and this part's the quotient. The remainder, this is the remainder, and b of x is this. So my answer is going to be x cubed plus 4, and I always do plus negative 18, which is the remainder, over x plus 2. So that is the answer to part 1, and that was probably worth 3 points. Or maybe 2, I'm not sure. I don't remember how we graded that one. But it says, is b of x a factor of a of x? And so we have to say no. B of x is not a factor of a of x. If, was it x plus 2? If x plus 2 were a factor, then we know by the remainder theorem that a of negative 2 would equal 0, since a of negative 2 does not equal 0. X plus 2 is not a factor. Done. That's it. Explain means words. All right, next problem's pretty easy too. Okay, every time you see one of these, man, New York State, you're getting boring, man. Boring. Now, of course, this year they're probably going to get cray-cray, but hopefully not. Every time we see one of these, they're always asking for a 95% confidence interval. And you got to remember that's plus and minus 2 standard deviations. And that is, in fact, what they're asking. Here's the information we need. This is all the information we need right here. So, based on this simulation of these results and all the data done, would 30 minutes be a plausible outcome? Now, remember, our mean is 29. All right, so all we got to do is figure out what the 95% confidence interval is, and if 30 minutes is in there, it's a plausible outcome. So the first thing we're going to do is find that. So we're going to take 29.101, and we're going to add and subtract 2 times the standard deviation, which is 0.934. So 29.101 plus 2 times 0.934. Enter. And we're also going to do the minus to give us the small n. So it's between 27, so we got 27.233 and 30.969. 30.969. Now the only hard part is don't round it wrong. So it's between 27.23 and 30.97. So that's the 95% confidence interval. Now, is 30 minutes between 27 minutes and 30.97 minutes? Yes. So, yes, 30 minutes is a plausible commute time. Since 30 minutes is within our 95% confidence interval. Done. That's it. 2 left, kiddos. All right, let me pause for a second. All righty. So as soon as I see this problem, by the way, there's a couple weird things about this problem, but as soon as I see this problem right there, there's one weird thing about this and it makes it a little bit more difficult. But as soon as I see that, I got to remember check answers. If it's a 4-point question, one of them's not going to work, kids. All right. Generally, we want to get the weird thing alone. So we would say, okay, 3 square roots of x equals 2x minus 5. Then I would divide by 3. But that's really weird, right? That's really weird. Now, to get rid of the radical, I got to square both sides. And that's really, really difficult to do. You got to square the top, square the bottom, all kinds of crazy stuff. So we're going to avoid that, but we got to be careful about it. I'm going to square this side and square this side. And I'm allowed to do that. But you got to remember, the 3 gets squared and the square root of x gets squared. So this side becomes 9x equals, now we'll write this twice. I'm going to simplify it a little bit. It's 4x squared minus 10x and minus 10x. That's minus 20x plus 25. Bring the 9x over. I get 0 equals 4x squared minus 29x plus 25. I'm going to use my calculator on this one because that factoring looks funky. I'm just going to come over here. And I'm going to say, okay. Get rid of all this so you can see some fresh stuff. Go back into calculator mode. Menu, 331, algebra, polytools. Find the roots. Always change this to complex. And it's 4, negative 29. And 25. And my answers are x equals 1 and x equals 25 over 4. So x equals 25 over 4 and x equals 1. Well, this x equals 1 is pretty easy. That's x minus 1. But if that's minus 1, doesn't this have to be negative 25 for these to get positive 25? And this has to be 4x. Right? So there are my two answers. Now, I know one of them's not going to work. So I'm going to store them in there. I'm going to store that most of the time one of them doesn't work. So 25 divided by 4, and it's probably this one, control var x. I'm going to type in the original problem, 3, and I am not going to use the equal sign, 3 square roots of x, enter. Oops. Original problem is 3 square roots of x minus 2x, enter, equals negative 5. Oh, and the right side's negative 5. Beautiful. So maybe both of them are going to work. Let me go back up here and do this 1. Enter. Hit the up arrow. So when I plug in 1, I get 1. I'm supposed to get negative 5. I get 1. So the 1 doesn't work. So my answer is 25 over 4. Now, if you turn that into a decimal, your decimal will be 6.25. All right, one left, the big one. This problem was a joke. The only problem with those problems, it just had big numbers. So we had to write, okay, so we're going to, woohoo, I got $318,000. That seems realistic. And we're going to invest it at 7% compounded annually. Well, they couldn't have picked an easier compounding for you. So that's nice. Uh-oh. All right, that's kind of nice. So we're going to start with A of t. Now, compounded annually is pretty simple. Start with 318,000. 1.07. Excuse me, not that. 1 plus 0.07. I want you to get in the habit of doing that as opposed to 1.07. 1 plus 0.07, because if this was compounded monthly, you'd have to divide just this by 12. If it was compounded quarterly, you would have to divide this by 4, so on and so forth, and multiply by 4t, or if it's 12 and 12t. But we don't have to do that. The nice part is it's just annually. They made it easy on us. So we just put a t there. Okay. Now, this is a little bit tricky. You know what this means? No arrows. You have to start at 0 and you have to end at 20. If you go past that, you lose a point for stupidity. Don't do that. So we're going to graph this thing. $318,000. 1 plus 0.07 raised to the x. You got to raise it to the x. Even though we got t here, we got to raise it to the x. Wow, I can't see it. I wonder why. You know why you can't see it? Because it starts at 318,000. All right, we don't need negatives, so I'm just going to make this 0. Now, I know it starts at 300,000, and it's going to keep going up. So, you know, it probably gets to 500,000. And then I'll press tab because they want us to go to 20. Oh, wait a second. I got to be able to see that. So I'm going to press... This is clearly not enough. I'm going to go 1 million. 1, 2, 3. 1, 2, 3. It's not enough. 1,500,000. Ah, now I can see it. See how it starts at 0 here, and we got 20? So it looks like I got to get to 1,500,000, but I'm not sure how much. So I'm going to go to Control T, and I'm going to see 0 is at 318. And I kind of knew that. We knew that. So the minimum... Come on, damn it. Doggone it. Why won't you let me... Okay, so that's not... I'm going to do it someplace up top, maybe. So I know my minimum is going to be 318,000. And I want to go to 20 to see what 20 is going to be like. 1,230,000. 1,230,559. Okay, so now I got to think about my scale. Now, I know there's 20 boxes along the bottom. I've seen that. All right, there's 20 boxes along the bottom. That's going to be easy. That scale will be just 1. So let me put that in. So I'm just going to go 2, 4. I'm not going to plot all these points anyway. 8, that'd be ludicrous. 10, 12, 14, 16, 18, and 20. And so there's 20 boxes up. 20 times 100,000 would be 2 million. 20 times 50,000 would only be 1 million. So that's going to be enough. So I'm going to make every one of these 200,000. Every 2 boxes, 200,000. I got to get to 1.2 million. I just got to make sure I get there. I don't want it to be too small, and I don't want it to be too big. So I got to double that. So 800,000. 1 million. 1,200,000. And 1,400,000. All right. Well, now we just got to go to the table and start plugging the numbers. 0 is 318,000. So let's see. 0, that's 300. So 318 is about right about there. 2 is 360. 3, about halfway, maybe a little bit more. 4 is 416. 416. 6 is 477. 10 is 625. Oh, I forgot 8. 8 is 550, around 550. 10 is 625. 12 is 717. 14 is 820. Doesn't have to be exact, right? You're not going to be able to do this exact. It's got to be close. 940 is 16. 18 is 1 million, about 1,010,000, somewhere around that. And 20 is 1,230,000, so that's 1 million. Oops. 1 million. So that's about here. Wait, this is 200. So this is 1,200,000. It's right about there. And that was 1,100,000. It's not more than 100. Oh, 18 is 1,020,000. Yeah, 18 is only one. Okay. So that's about right. Try to hit the points. Resist the temptation. Resist the temptation to put arrows, kids. All right, we're almost done. This problem is just about finished. The question says solve this for when it equals $1 million. So algebraically, when it equals $1 million. So 1 million equals 318,000. 1 plus 0.07 to the t. You know you got to get the weird thing alone, so we're going to divide by 318,000. Get rid of some zeros so you don't have as less writing to do. That's called casting out zeros. So I get 1,000 over 318 equals 1 plus 0.07 to the t. Now this is an exponential function. In order to solve it, we're going to do log. So log, this is your base, and this is your exponent. So bases go down here, 1 plus 0.07. Logs are equal to exponents, so I put a t there. And then the 1,000 over 318 goes here. So believe it or not, that's all I got to type in. Control log 1 plus 0.07. Control division 1,000 divided by 318. And I get 16.9335. So t equals 16.9335. It said rounded to the nearest year. So t equals 17. Shabam! 17 years, I'll be a millionaire. Explain how your graph from A of t confirms your answer. Well, let's see if it does confirm it. 1 million. Now, make sure you use dotted. Now, had I hit these points, and you probably did, I hope, you'd see that it's just about perfect right there. So, what you need to say is, if I graph the line y equals 1 million, it intersects my function at t equals 17 years. Therefore, 17 is the answer. T equals 17 years is the answer. That's it. That wasn't bad. That wasn't bad at all. Kids, that's all the Regents I got for you right now. Of course, after the June Regents, once the June Regents is out, I'm gonna burn those as fast as possible. I believe New York State says I gotta wait a week before I can upload them. I'll have them made. They'll be sitting on my home computer at home. I'll have them made, but I cannot upload them or do anything with YouTube until New York State says I can. And I apologize for that. We used to be able to get them out quicker, and I know you're dying to know what you got and what you did wrong and what you didn't do wrong. So I will make the videos as soon as I can. Other than that, you guys keep studying, keep working hard. Check back to my website, because somewhere on there at some point I'm going to put a video on how to get my, wait, I don't know if I could, well, I'll do it. I'll put a video on there how to get to my flashcards, and there's about 260 of them. It should be up soon, okay? All right, guys, good luck. Hit the subscribe button, hit the like button, and keep studying. Don't quit. Do not quit. You can do this.